Manchester, one of Britain's major cities, has been the hub of much technological development and change in its time. With this must be included developments in computing. The world's first stored program computer was built at Manchester University in the late 1940s, and Manchester now boasts one of the largest educational computer centres in the world. The University of Manchester Regional Computer Centre, UMRCC, constitutes part of a vast educational complex. These machines provide the computer power and storage facilities for research and teaching in higher educational establishments throughout the United Kingdom. The Northwest universities were the first external users of UMRCC. Universities throughout Britain began to use the service as communications links with the centre improved. Some polytechnics began to use UMRCC in 1977, and now Research Council sites also use UMRCC facilities. The current national scene has over 50 universities, research establishments and polytechnics being served by Manchester's Regional Computer Centre. The communications technology which facilitates this service is highly sophisticated and is constantly being refined. Telecoms lines provide the basis for communications between remote sites and UMRCC. At its simplest, a remote site may have a direct line to UMRCC, where a remote job entry station, often the site's local computer, enables job submission through a local terminal. Results are returned, usually printed on the remote site line printer, or saved in an area of the site's computer file store. Work can also be channeled to UMRCC via the joint academic network JANET. Providing a site supports a JANET connection, a user can either log in via a terminal to UMRCC or submit work via a transfer protocol. Throughout the country, there are Network Operation Centres, NOCs, or main switches, which sites can use to route their calls to specific machines. UMRCC has an address for users to access their system, but it also acts as an NOC, giving users access to other sites, for example, Strathclyde. JANET transmits data by the best route to and from sites, either directly or via another NOC. The most heavily used JANET trunk lines transmit at the highest speed of 48 kilobits per second. The rest at 9.6 kilobits per second. The speed of terminals depends upon the way sites configure them to the network. As long as a site is on the JANET network, users now have the opportunity of logging into it from almost any university in the country. Potentially, this introduces considerable flexibility to the academic computing community. Keeping pace with new developments, the regional centre has been subject to much change. This was the first computer developed at Manchester University in 1948. This prototype was then produced commercially by Ferranti Limited. Here is a logic unit of a Ferranti computer from 1951. By 1961, the same computer function could be performed cheaper and faster by this printed circuit board containing transistors. 10 years on, integrated circuit chips like this enabled the same job to be done at a fraction of the cost. The invention of the microprocessor opened a new era of electronics and computers. Since then, the development of microchip technology has provided the means of making systems smaller and cheaper. At one end of the scale, introducing computers and chip-controlled devices into people's homes, making them an acceptable everyday tool in our lives. And at the other end of the scale, creating large systems with phenomenal processor capabilities. Technological growth continues to provide the means of expanding and improving the University of Manchester Regional Computer Centre. UMRCC uses a configuration of 5 main computers. The computers are linked together via a loosely coupled network, LCN, permitting traffic between the machines. The front-end processor is an Amdahl V8, which is mainly used to store and manipulate files and schedule jobs for the back-end machines and communicate with other sites. Attached to this is a mass store device to supplement file store and provide file store backup. This is a very efficient retrieval system. Special cartridges of wide high-density tape are used to store information. Retrieval is automatic. No operator intervention is required. Connecting the AMDAL with the academic computing community are the centre's communications processors and Janet switch. The AMDAL computer channels users' jobs to the 4 back-end computers. Users can choose to run their jobs on one of 2 CDC 7600s, a Cyber 176 or a Cyber 205 vector processor. Results are guided back through the AMDAL onto line printers centrally or into the AMDAL file store for users to interrogate at a terminal or passed to remote sites. If graphics or microfilm output is requested, the job will be output to magnetic tape. This is then used on the offline graph plotter system to produce pen or electrostatic plots. Alternatively, the offline microfilm system can produce microfilm or microfiche output. This amount of line printer output can be produced on 3 microfiche, making microfilm more economical in both space and material costs. The back-end computers are used for processing the majority of user work. The 2 CDC 7600s and the Cyber 176 run similar operating systems and applications software. They have identical central processors. Each central processor has 9 separate functional units which work independently and simultaneously. The functional units can add, multiply, divide and subtract different numbers concurrently, producing results at a very high speed, the maximum rate being one result every 27.5 nanoseconds. All the memory is real memory, and there is no virtual memory. The CDC 7600 computers have been considered large mainframes, used particularly for large-scale numerical problems. However, the Cyber 205, the 4th back-end computer, is a vector processor with virtual memory lending itself to certain types of very large-scale applications. The virtual memory means the system is not limited by its real memory. Addressable space appears to the user as real storage locations. The only limitation is set by the addressing scheme of the computer and by the amount of auxiliary storage available. The 205 has 2 vector processors known as vector pipes and a scalar processor, each running simultaneously and separately. The 205 is particularly suited to large problems that can be expressed in terms of long vectors. It's interesting to note that the 7600 is capable of 10 megaflops, 10 million floating point operations per second, whereas the maximum on the UMRCC 205, using special vector operations, is 200 megaflops, 400 if using half precision. UMRCC was the 3rd site in Europe and the 2nd in the UK, the Met Office being the first to install a Cyber 205, one of the most powerful computers to be developed. NASA houses both CDC 7600s and a Cyber 205, similar to those at Manchester. Such powerful machines are necessary to carry out their work in space research. The UMRCC computers are used in some notable research in the UK. Bidston Observatory accesses the facilities at UMRCC. It is a major centre for tidal research and is part of the Institute of Oceanographic Sciences belonging to the Natural Environment Research Council, NERC. In its early days, tidal prediction was assisted by this machine, an analog computer designed by Arthur Doodson, who was director between 1945 and 1960. Each harmonic constituent of the tide is represented by the vertical motion of a pulley wheel, constrained to move harmonically at the appropriate speed. A wire wound over several such wheels sums their motion and records it. The calculations made by the various groups at Bidston are performed these days on electronic computers. The Cyber 205 at UMRCC is used by the Numerical Modelling Group. Amongst its areas of study, this group has developed modelling for the prediction of storm surges. Floods can take a heavy toll if they strike without warning. By using storm surge models, developed by Bidston scientists in conjunction with weather prediction models at the Met Office, storm surges can be forecast. The numerical models are applied on a